Good morning, everyone. So welcome to my YouTube channel, Math Satra. So today we are going to see 26th lecture on Riemann integration. So today we are going to study how to change a variable in integration. Okay, this is used very oftenly in integration. Okay, change of a variable in an integration. Suppose you have a function f that is Riemann integral, and another function you have a phi that is strictly monotonic function. Okay, and its derivative is Riemann integral. Okay, so f is here defined on closed interval a b, and phi is defined on closed interval alpha beta. The a is equal to phi alpha and b is equal to phi beta. Okay, then the integration a to b fx dx is equal to integration alpha to beta phi compose f compose phi y, the derivative of phi dy. Okay, so how to prove this result actually? Okay, so let take P be a partition of closed interval AB. So this is the partition of closed interval AB. Okay, you observe one thing about phi. Phi is strictly monotonic function with a is equal to phi alpha and b is equal to phi beta. Okay? Without loss of generality, we are assuming that phi is monotonically increasing function, because same if we will prove this theorem for or result for monotonically increasing function, same thing you can repeat on for monotonically decreasing function, strictly monotonically decreasing function, then proof will be followed. So we will prove this theorem for phi as a strictly monotonically increasing function. Okay? So phi is strictly monotonically increasing function, and a is equal to phi alpha, b is equal to phi beta. So phi, we can restrict our function because the range of domain, what is the range of phi? Because this function is monotonically increasing, and at initial point it is taking value, it is taking value a, and at final point beta it is taking b. So this is function actually from alpha beta to ab. Okay, this is 1 1 and 1 2. Okay, so this is invertible function, because every strictly monotonically increasing or decreasing function is always 1 1, and this is on to here from alpha beta interval to ab, so it is invertible function. Okay, so phi inverse will exist. So I am putting x is equal to phi y, so we get phi inverse x is equal to y. We write yi is equal to phi inverse xi for I goes to 0 to n. Then corresponding to partition B, we get another partition Q by this, taking the pre-image of xi. Okay, yi is here, phi inverse xi. So we got partition of Q, alpha is equal to y naught, and that is still less than y1, that is still less than y2, up to yn is equal to beta is a partition of alpha beta. Okay, now phi is differentiable. Okay, phi is differentiable because in theorem it is given that the derivative function of phi is Riemann integrable. Okay, so what we have, we can apply mean value theorem, or you can say Lagrange's mean value theorem. Phi yi minus phi y minus I upon yi minus yi. We are applying mean value theorem on the closed subinterval yi minus 1 to yi. So there will be some eta I by mean value theorem. Okay, that is equal to derivative at eta I. Okay, so what is this? This is nothing but xi minus 1. Okay, so it will become delta xi upon delta yi. So solve it. So we got this for I goes to 1 to n. Okay, now I am taking xi I equal to phi eta I. Okay, eta I for I goes to 1 to n. And Now we can consider the Riemann sum of F. Okay, so what is this? I'm taking J I this. Okay, so this will belongs to this interval because phi is function from alpha beta to AB. So, and it is mapping xi minus 1, xi minus 1, xi interval to yi minus 1, yi. Okay, sorry. So this is mapping the interval yi minus 1, yi to xi minus 1 to xi interval. So I can take ji here in Riemann sum. Now put the value of ji here, that is phi it I, and delta xi value is this. Derivative of phi at eta I into delta yi. Okay, so put this value. Now what is this? This is phi, f composed phi eta I into derivative of phi eta I delta yi. So this is nothing but Riemann sum of f composed phi. Note that this composition phi, f composed phi is Riemann integral. However, composition of two Riemann integral function is not Riemann integral, but this is Riemann integral because this phi is a strictly monotonically increasing function and it is continuous. Okay, so its inverse will exist and it is also continuous and it is uniformly continuous. So we are making compositions from uniformly continuous. Okay, so that is why it is Riemann integral functions. Okay, here you can check it. Here derivative function is also Riemann integrable, so their product will be Riemann integrable. Okay, so this is Riemann sum of f composed phi. On left hand side that is Riemann sum of f. Okay, so now observe one thing, phi is continuous and strictly monotonically increasing function. This is 1 on 2 also. Okay, because strictly monotonically increasing function is 1 so extra thing 1 is written. However, strictly monotonically implies that function will be 1 because this is on 2 also, so inverse exists. Okay, now why it is continuous? Because it is differentiable function. Now if you have a continuous function on an interval that is monotonically increasing and onto function, then the inverse is also continuous. And we have a inverse is also continuous, phi inverse is continuous here. And we know that every continuous function on a closed interval is uniformly continuous. So therefore, phi inverse is uniformly continuous. We get, so we know that what is the definition of uniformly continuous? We have some criteria. If the difference of two values x and y tends to 0, their corresponding image also tends to 0. Okay, the difference of their corresponding images also tends to 0. So here if the norm of partition tends to 0, because phi inverse is uniformly continuous, the norm of Q will also tends to 0. Okay, but it follows from continuity, uniformly continuity. So letting norm of P tending to 0 in 1, we get, because once norm tends to 0 of P, the norm of Q will also tends to 0. So in place of right hand side of, in place of P, we can write norm of Q tending to 0. Now that both the functions are Riemann integrable. So Riemann, once you take a norm of partition tending to 0, it will convert to integration. So this is a to b fx dx. And this is nothing but alpha to beta f composed phi y, phi dash y dy. Okay, so this is done. Okay, because this left hand side will converge to this integration, right hand side will converge to this integration. Okay, so today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. Thank you very much for today's lecture. Thank you very much.